In this video, we're going to evaluate this definite integral involving an arc sine of 2x in this case. Based on what we have in the denominator, I would say that a good choice for u would be arc sine of 2x. And just to remind you, the derivative of arc sine of u is equal to 1 over the square root of 1 minus u squared times du over dx. So with that in mind, we'll let u equal to arc sine of 2x. So computing derivatives here, on the left side we get du is equal to, and as we just saw, the derivative of arc sine would be 1 over the square root of 1 minus u squared. Well, in this case, the u in the formula, of course in this case I have a different u here, but the u in the formula is 2x, the square of that is 4x squared, and then this will be dx. So again, this is a typical U-substitution, solving for dx, and of course the derivative of 2x is 2, so I need a 2 up here using the chain rule. This will be a 2 there. So solving for dx, multiply both sides by square root 1 minus 4x squared, and then also divide by 2. I'll put this 2 out here. So this is equal to, now we just want to transform this integral into the variable u. So obviously the numerator will be u. U is arc sine of 2x, so this is u up here. And dx is replaced by the square root of 1 minus 4x squared over 2. And then of course we have the square root of 1 minus 4x squared in the denominator. So this cancels out here, this cancels out here, and of course this is also du here. So this gives me then, put the 1/2 out in front here, and I got the integral from 0 to 1/4. It's just this plain old u here, du. Use the general power rule here to integrate, so we add a 1 to the exponent here, it'll be 2, and divide. That'll give us, it'll make this 1/4, and this will be u squared over 2. And of course I already have the 2 over here. Then we're going to integrate from 0 to 1/4. Now I could change the limits here so everything is in u, but I'll just go ahead and leave it, convert back to the original variable x. So the u is arc sine, so this will be squared arc sine of 2x, and this is squared, and the limits here would be from 0 to 1/4. So then we evaluate this at 1/4. So this will be arc sine, and put in the 1/4 there where the x is. That'll give me 1/2 arc sine of 1/2. That's quantity squared, and then it's minus 1/4 arc sine. Evaluate that at 0. This will give me 0 here, and that's squared. Now the domain for the arc sine is between -1 and 1 inclusive, and the range is from negative pi over 2 to pi over 2. That seems to be the order here. This would be 1/4 here. So arc sine of 1/2 is pi over 6, and that's quantity squared. And arc sine of 0 is 0 times the minus a 4th. That's still going to be 0. So this will give us pi squared over 36 times the 1/4. So this will come out to pi squared over 144. And that's the exact answer. You could use a calculator and square the pi and then divide by 144. You get something like 0.069, but we'll leave it in this format here. Thanks for watching. We'll see you next time.